All right, so this week we're going to take a look at writing equations in y equals mx plus b. Okay, that's the slope-intercept format. And we're going to look at a few things. First thing we're going to look at is what the formula is, okay, how we write an equation in that formula. We'll do a couple examples. And then I'm going to give you some kind of keywords to look for that means slope. Because the worksheet on Wednesday, it's got different situations it's going to give you as like word problems. And we just have to be able to identify what words in that problem are the really important ones. Okay, so I'll give you some hints in a little bit. All right, so let's start out with just writing what slope-intercept form is. Okay, I think I already said it a couple times. But can someone remind me what is the equation that we use when we're writing lines in that certain format? It's the y equals, and what's the rest of that? Oh, man?
Y equals mx plus b.
Yeah, it's y equals mx plus b. Okay, so where it says slope-intercept form, you're going to want to write that down. That's the equation we'll be using all week. Okay. That's not the only way to write the equation of a line, but it is the way we're going to use this week. Okay. Can somebody remind me when you have these two letters, the M and the B, okay, those each stand for something. Can anyone remind me, what does the M stand for? Yeah, that's the slope. Okay. So that's what we looked at last week. Okay, it tells me how steep the line is. That's the rise over run. And what does the B stand for? No. Yeah. Exactly. Perfect. That's your y-intercept. So if you have a line, okay, like on an xy axis, like that, the y-intercept is where it crosses the y-axis. It's that coordinate right there. Okay, that's your y-intercept. And then the steepness of that line, that's the slope. So when we write an equation in y equals mx plus b form, those two arrows that I have pointing to these two letters have to change to numbers. Okay? The x, in a final answer, the x is going to stay as x, and the y is going to stay as y. I think you already have those two things written down. So an example of a final answer would be something like y equals, I'm just making this up, 2x plus 4. That's what a final answer looks like in slope-intercept form. You fill in a number for the m, whatever number they tell you, and you fill in a number for the b, again, whatever number they tell you, and that's how you write the final answer. Okay, so the slope, I think this week, for the most part, we're not going to have to do as much calculating for the slope. They're going to give it to us. We just have to be able to read the word problem and know which number in the word problem is the slope. Okay, so that's where I'm going to give you some hints at what to look for. But in general, slope is going to be some sort of rate. All right? So we're going to do a problem. It says on the worksheet, I'm not even going to read the whole thing, but I'm just looking at part of the sentence. It says $200 per month. Okay. Anytime you see something that has the word per, that means it's a rate. Like if you make, $15 per hour, that's the rate of money you make per hour. Okay, so the word per is a good hint that that number is the slope, because that's a rate. Okay, and the y-intercept, again, I'm going to give you some hints at words you can kind of look for, but a y-intercept is like it's like a starting point. Okay? It could also be like a one-time fee you have to pay. So for example, let's say that you had to pay like $50 per month for your cell phone, but you had to buy the phone, and that was like $400. Okay, so the $400, that's a one-time fee. You don't keep paying for the cell phone every month. So the $400, you pay at one time. That's like a y-intercept. $50 you pay every month. for the bill, that's like the slope, because it's a rate. It's the rate you have to keep paying over and over and over. Okay, so slope is like the thing you keep paying over and over, but you only pay for the phone one time. And that number is usually added or subtracted right on the end. If it's a positive y-intercept, you'd see a plus sign in front of B. If it's a negative y-intercept, you'd see a minus sign in front of the B. So look for the starting point, extra fees, something that is added or subtracted on, it should say, the end. I don't know why that didn't print on yours, but it should say it's added or subtracted on that end. Okay, it's the B value. Okay, and just in case so we don't forget, I'll put the letter above it. Slope is M, and B is the y-intercept. Okay. Anything there anybody needs to copy down? All right, so let's try an example. And let's see if we can figure out which number is the slope, which number is the y-intercept. Okay. So you guys have this printed. It's on the back of the first page. It says a city parking garage charges a rate of $3 for parking 2 hours or less, and then they charge 50 cents per hour for each hour after that. Write a linear model, that means write an equation in y equals mx plus b, that gives the total charge basically that you're going to have to pay to park your car. Okay, so we've got two numbers. Okay, let's start out with the easy one. From the notes on the front, what did I say is going to happen to the y variable when you write your final answer? It says the y variable, what? Yep.
It's going to stay as y.
It's just going to stay as y. So this stays as y. So that doesn't change. How about, let's just write down the whole formula we're going to use. Okay, so we got the y. How about the x? What's going to happen to the x in that formula when we write our final answer? How about, Gigi, what happens to the x?
It's going to be multiplied to the slope.
Okay, yeah, it's going to be multiplied by the slope, but what happens to the letter x itself? Yep. Yeah, it stays as x. So the x variable stays as x. Okay, that doesn't change. Okay, now we got to figure out which number is the m and which number is the b. So we have a flat fee or a rate, okay, and then we have the 50 cents, which we have to keep paying over and over. So which number there is the number we keep paying again and again? Yep.
Can I go to the bathroom?
Yeah. Does anybody know which number we keep paying again and again?
50 cents.
Yeah, the 50 cents. How do I know? The keyword there is per hour. I have to keep paying 50 cents every hour that my car is parked. And B is like the one time we pay it one time. So what's the number in this problem that we only pay one time? Yep.
3.
Yep, $3. Okay, you don't keep paying $3 every hour. That's not what it says. It says you pay $3 like when you pull in, and then you pay 50 cents per hour after that. Right. So now we just have to fill in everything we have here for the letters there. So y stays as y. I didn't write this down, but the equal sign stays as the equal sign. For m, we're going to plug in 50 cents. That's my m. For the x, that's going to stay as the x. And for the b, that's a positive $3. Okay, if it was like a negative $3, that would be like they're paying you $3. That's not what's happening here. We might do a problem where you get paid money, but in this one, no, it's you have to pay the company to park your car. So it's plus $3. And that's the equation they'd be looking for that represents that situation. Now, in this one, they're not going to have you do it, but in some on the worksheet they will. They're going to say, now use your formula to find out the cost if you park your car for 6 hours. What would you have to do with the number 6 and this formula to figure out how much it costs to park the car for 6 hours? What do you think you'd do with the number 6? How about Don, do you have a guess what you would do with the number 6?
Plug it into the X.
Yeah, you'd plug it in for the X. Okay, so if they said it's going to cost, if they say, well, what's the cost to park your car for 6 hours? You just plug it in for the X, right? And that would give you the cost to park the car. Now, I know it says like it's only 50 cents you pay after the first 2 hours. That makes it a little tricky to figure that part out, but we're just going to go with you plug it in for X, and then you do out the math on the calculator. All right, let's look at this one. So it says a feather blew out of a nest that was 10 feet in the air. Okay, so we know this 10 is going to be something. It's either going to be something that's happening over and over, or it's going to be like a one-time value. And it says the feather drifted to the ground at a rate of 2 feet per second. Okay, write an equation that represents that situation. All right, so let's start with the y. Isaac, when we write an equation in y equals mx plus b, what happens to the y? Stays the same. Yep. Stays as y. Ellie, what's going to happen to the x? Yep, that's also going to stay the same. Perfect. Stays as x. Okay, now we're going to figure out which number here is the slope. Remember, the slope is the one that has something to do with like a rate. It's a number that's going to keep happening. Yep?
It's 2 feet per second.
Right. So the slope is going to have something to do with this number. Now think about what's happening to the feather, right? Which way is the feather moving? It's moving down, right? The feather's not going up. Like when we parked our car, the amount of money that we had to pay continued to go up the longer you park your car. Well, the feather, the longer the time goes by, the lower the feather is going to get. The feather's not going up. So what kind of number do you think that means the slope is going to be because it's drifting towards the ground? Yeah?
Negative.
Right. So the slope here is -2. The negative represents the feather falling. If you did +2, that would mean the feather's going up. Okay, but it's falling down. All right, so we got -2 for the slope. And then the y-intercept is going to be, in this problem, kind of like the starting value. Okay? So the y-intercept is like a starting point in this problem. It's not a feet. It's not like parking the car, but it is like a starting point. What height does the feather start at?
10 feet.
10 feet. And that 10 feet doesn't keep happening over and over. That's like a one-time thing. The feather starts at 10 feet, and then as it falls, it's never back at 10 feet again. That's just where it started. All right, so using this equation, anybody think they can give me the final answer, just filling in our information in this problem? Well, Eli, could you give me what the equation would be?
Y equals -2x plus 10.
Plus 10. Perfect. That's the equation. And x represents the number of seconds that the feather's been falling. Okay, so let's say I wanted you to figure out how high the feather is going to be in 2 seconds. Or let's say 3 seconds. 3 seconds. What do you think I would do with the number 3 to figure out how high the feather is going to be? Yeah, where would you plug it in? Yep, you'd plug it in for x. And if you plugged it in, you'd get -2 times 3. -2 times 3 gives me -6. And then I add 10, because there's a plus 10 on the end. And that means after 3 seconds, the feather would be 4 feet off the ground. Now, there is a limit to how high of a number you could plug in here practically, because eventually if you start plugging in too big of a number for x, you're going to start getting a negative number. And it doesn't make sense that the height of the feather would ever be negative. What's the lowest number that you think the height of the feather could be off the ground?
0.
Yeah, it can't go below 0. Once it hits the ground, it's at a height of 0, and that's it. And that would happen at 5 seconds in this problem. After 5 seconds, it doesn't make sense to use this formula anymore because the feather stopped falling. All right, any question on that? All right, so let's on the, I think we got one more of those. Yeah. Oh, just one more page of notes. It's not another example. Okay, just some keywords that kind of give you a hint of what a y-intercept is. Okay, let's look back at the last problem. A feather blew out of 10 feet in the air. So keywords for y-intercept. Something that's like a start value or an initial value. Another thing you might see is like a one-time fee. Okay, something that you pay one time, like maybe to join a club. You have to pay a $100 initiation fee, and then you have to pay $10 every month after that. That initiation fee you pay one time. Let's see. So start value, one-time fee. Let's looking at some other examples. I think that pretty much covers most of the kind of examples that you're going to see. All right, keywords for slope. Something you might see for that is the word per. Okay, the word per means it's something that you're going to pay over and over, per month, per hour, per day, per week. Okay, something like that. What else? The word rate. Okay, like in the feather problem, the feather was falling at a rate of 2 feet per second. That's another indication that the number is slope. Let's see. I'm just looking at different examples you guys are going to see. And just remember, when you see slope, if you see something like decreasing or falling, this means the slope is negative. All right, so if you see like the level of water is dropping at 2 feet per year, maybe they're not getting enough rain or something, not like today, but they're not getting enough rain, and the level of the lake is dropping at 2 feet per year, that's a negative slope. If it said the level of water in the lake is rising at 2 feet per year, that's a positive slope. Okay, so you got to keep in mind if the slope should be a negative number. Okay. I'll just add a couple words here. So increasing or rising, that would be a positive slope. Okay, so those are pretty much the hints at what you're going to be looking for. Okay, any question on that? Okay, so now on the MCAS question, they give you an equation and they ask you to pick out the slope and the y-intercept. I just showed you guys earlier what the y-intercept is in red, right there. Next problem is about an airplane that's at a starting altitude and then the plane begins to descend. What kind of slope do you think that would be if the plane is descending? Negative, it's going down. Number 3, it's about a company that rents a car and you can either pay $25 up front or 10 cents a mile, or you can pay a little bit less up front, but then you pay more per mile. And it asks you which equation represents that situation. All right, and then the last one is another graph. Okay, so that, I think, pretty much covers what you need to know on y equals mx plus b.